Okay, class, this is question 45. It says match each graph below with the correct inequality. Let's take a quick review of inequality symbols that we have here. So the top two are greater than and then less than in that order. So the first one here, this is greater than, this is less than. And if we're solving a inequality with just one variable, right? That's on a number line. That's the solution's restricted to a number line. And in the case that we've got these symbols, we would have an open boundary point, right? So on our number line, if we sketch the number line, somewhere on that number line, we would have an open circle indicating that that point, although it's the boundary, is not included in the solution. Whereas if we've got the greater than or equal to here, or the less than or equal to here, on a number line, right, we would shade in this dot indicating that that point is a solution. So something similar happens when we're looking at inequalities that involve two variables, x and y, and we're graphing them on the Cartesian coordinate plane. If we've got greater than or less than, our boundary is a dashed line, meaning that this line separates the Cartesian coordinate plane into two places: values of x and y that work and values of x and y that do not work, right? And we determine that by doing a quick test to see which side above or below is a solution. Now, if we've got greater than or equal to, or we've got the less than or equal to, our boundary is a solid line, meaning that not only is one side of that line included, but the line itself is also part of the solution. So that's what's happening here when we shade in the dot. It means that dot is a solution, but also with the line, it means the points on the line are solutions as well. So that's just a quick review of those symbols and how we know our boundary line or our boundary points if they're solid or shaded. So when we look at this in part A, right, option A, you can see that this has got the greater than, right? So our boundary there would have to be a dash line. The next one has a less than, so my boundary there would have to be a dash line also. The next one, C, has the greater than or equal to, so I know that that boundary is going to be a solid line. And then the last one there is less than or equal to. That boundary is going to be a solid line as well. So the other thing is all four of these are in slope-intercepts form, so it's pretty simple for us to graph these. The first one is y values are strictly greater than the opposite of x plus 2. So we've got a y-intercept of 2 and a slope of -1, down 1 over 1. And it says y values are those things above that line, right? Y's are above it. So if you look at that, this one right here where y-intercept is at 1, is at 2, and then we've got a slope of down 1 over 1, down 1 over 1. So this has a slope of -1. It has a y-intercept at 2. It's a dashed boundary line, so that would be strictly greater than. And it's this. So number 3 is clearly A. So we can write it right here. Number 3, we'll say goes with A. Let's look at B. B is less than. So that's when your inequality is written in standard form like this. And I know I probably shouldn't say this, but if it is in standard form like this, and the y is over on the left-hand side, when it says y values are less than the curve, that's kind of how I interpret this. So this says y values are less than the curve, or in this case the line, 2x minus 3. So we've got a y-intercept of -3 rather, and a slope of +2. And if you look right here, sure enough, 1, 2, there's our -3, and then this is up 2 units over 1, up 2 units over 1. So this is it. And you can see that it is a dashed boundary line, which it needs to be, and it's everything that is below that line. So you can see my y values are less than that curve 2x minus 3. So number 1 goes with B. And let's go over to, let's see, C. There's only two options left, right? We can go 2 or 4. C is interesting. It's got a y-intercept of 0. 4 is the only one where that happens. So this is probably our solution. However, it is nice to also check that, yes, the boundary line is solid, right? And it's shaded above the line. So it's including the boundary and it's above the line. And our slope is indeed up 1 over 2 units. So number 4 definitely goes with C. That means by default, 2 better go with D. On 2, you can see we've got a y-intercept at 2 units. Our slope is down 2 units over 3. You can count it down 1 unit, down 2 units, and then over 1, 2, 3 units. It is a solid boundary line, and it's everything below that solid boundary line. So 2 is going to go with D. All right, that's it for question 45.